Hello everyone. I am sharing with you question which came in Tifr 2019. The question is based on true or false. The question is there exists a continuous function from reals to reals such that fq is contained in r minus q, that is the image set of rational is contained in irrational, and the image set of irrational is contained in q. We have to tell whether such function exists or not. Okay, so let's start with the solution. uh, we know if any function from a to b, if it is given as 1 1, we know that the cardinality of A will be less than equal to cardinality of B. We have already done this. Okay. We know that the cardinality in lower classes in +1, +2, we have already done this, that the cardinality of A will be less than equal to cardinality of B. Also, if the function is given as onto, then what will happen? Then the cardinality of A will be greater than equal to cardinality of B. This we also know. And if the function is 1 1 as well as on 2, then the cardinality of A will be equal to cardinality of B. So we will be using this result. We can always restrict the function. We can always restrict the codomain of function to the range of function to make it onto function. So we can say that the cardinality of FA will be less than equal to cardinality of A by using this result. If the function is onto, then the cardinality of A will be greater than equal to cardinality of B. We are restricting the codomain of any function. We are restricting the codomain of any function to the range of function to make it onto. So the cardinality of FA will be less than equal to cardinality of A by using this result. Now, how will we will use this result in this question? We know that the image of rational is contained in the irrational. So by using this result, we know that the image set of rationals cardinality will be less than equal to cardinality of rationals. Since the rational is countable, so the image set of irrational will be at most countable. It can be finite also. Will be at most countable, as it can be finite also. Okay, but it cannot be uncountable, because if it will be uncountable, then the cardinality of fq will never be less than equal to cardinality of q. So it will be at most countable. Also, the image set of irrational is contained in rational, and the Q is countable set. Therefore, the subset of any countable set will either be countable or finite, that is at most countable. So F R minus Q will be at most countable, as we can say that FR is equal to image set of reals will be equal to image set of rationals union image set of irrationals. Okay, because we know that a real number is nothing but a irrational, either it is rational or it is irrational. So we can write image set of reals as a image set of rationals union image set of irrational. Since this is utmost countable and this is also utmost countable, therefore the union of utmost countable set is also utmost countable. Therefore f bar will be utmost countable. Also the function is given as continuous. So we know that the continuous function maps connected set to the connected set. Since R is connected, R is connected, therefore FR will also be connected. Will also be connected because the image of connected set will be connected as the function is continuous. So FR, as we know that FR is a subset of R because the codomain is given as R. Okay, so FR will be subset of R and also it is a connected. So what are the connected subsets of R? The connected subsets of R are either intervals, connected subsets of R are either intervals or singleton set. Okay, empty set is also connected, but FR will not be empty here because we know that the image of empty set is empty. Image of non-empty set can never be empty. So we are not considering this empty set here. Empty set is always connected. This is true. So FR can be interval or singleton set. Okay, but FR is at most countable, as we have already done that FR is at most countable since all intervals are uncountable. Since all intervals are uncountable, therefore FR will not equal to interval. FR will not equal to interval. FR will be equal to singleton set, some singleton set. Okay, where A will belong to real. So A, FR is a singleton set A, where A can be either, A will be real, A can be rational, or A can be irrational. Okay, if A is rational and we know that the image set of A, if A is rational, we know that the image set of rational is contained in irrational. Okay, we know that the image set of rational is contained in irrational. Therefore, if A is rational, therefore F of rational will not be contained in irrational, which will contradict. Okay, which will contradict, as it is a given that the image set of rational is contained in irrational. If A belonging to rational, F rational will never be contained in irrationals. Okay, if A belonging to irrational, if A will belong to irrational, then F of this will not be contained in rationals. Okay, so it will contradict our given statement. So A can be rational at one time or it can be irrational. It can't be both at one time, but we need both the irrational or rational so that our image set of rational will be contained in irrational and the image set of irrational will be contained in rational. So there is no continuous function. There is no continuous function satisfying the given condition. Hence, the answer will be false. The answer will be false. Let me tell you last step again. Since FR should be connected as well as countable, therefore we are left with one possibility that FR should be singleton A. Singleton A, where A is a real. So A is a real, so A either can be rational or A either can be irrational. But the image set of a rational is, if A is rational, then the image set of a rational will not be contained in irrational, because the image set of rational will be contained in singleton A. Okay, because the image of every rational will be A. It will be constant function. It will be constant function. No, if the range of reals is A, singleton A, this means that the function is a constant, and the image of every element will be A, this rational. So, but the image of every rational will be irrational, but here A is rational, so it will contradict our given condition. So, if A belonging to irrational, then it will contradict our condition that the image of irrational should be rational, because the image set of irrational is contained in the set of rational. So it will contradict this condition, because the image of irrational in this case will be A, which is irrational, which we are assuming irrational. So it will contradict this condition. Okay, so there is no continuous function satisfying the given condition, hence the answer will be false. Thank you so much.